Hello, crazy math nerds. It's the craziest math nerd here. I want to talk to you a little bit about differential equations today. And we've already really talked about differential equations in that we talked about that in the last time. And so a differential equation is that if there's a derivative equal to something. And this is actually considered a simple differential equation because the people over here, the function that's equal to, is just has x's in it. And so we've talked about that. And many times when we're asked to find the y, they'll say find the solution to this. And so all of these words mean that I just really want to find the y, that if you take the derivative of them, of it, you get 5x cubed. And we've been doing this, but we've been doing it a little bit informally. So we're going to get a little bit more formal with this. And then I'm going to write the dy down. And then I'm going to swing the dx over to this side. And so what that allows me to do is actually to have two differentials here on both sides, and I can integrate both sides with respect to their variable. So this is like having a 1 there. So if I integrate 1 dy, I'm trying to say, who do you take the derivative of and get 1 with respect to y? And that would be y. And then if I'm trying to find out where this guy comes from, it's a power, so I have to do the anti-power rule, and that is add a power and divide, and don't forget the constant of integration. So this is called the solution to the differential equation. It's also what we've been calling, we've been saying, who do you take the derivative of and get this differential equation? We've been kind of doing that. But it's also called a solution, and that c is the constant of integration. And this is called a general solution. And a general solution has this constant in it, okay? All right. So why did we make that so specific about it's a general solution? Because this can be any number, and so this is actually an answer that is a family of answers. So if we know something about the original function that we take the derivative of and get this, then we can actually find a particular solution because we can solve for c. So this is a page from Master Math Mentor, and I'm sorry I don't know the page number. This is one of his problems. And so he gives us the derivative and gives us a point on the original. So if we're asked to solve the differential equations with the given initial conditions, that's that point, then what they want us to do is after we actually kind of do this solving thing like we did in this problem here, so let's go ahead and do that. So if f prime is equal to that, where or who do you take the derivative of and get this? That'd be 3x squared over 2 anti-power rule minus x plus c. So if you put this initial condition in, you can actually solve for c. The 3 is your f of x or your y, so that yields 3 equals, put the 2 in for x, and now I can solve for c. So 2 squared is 4, divided by 2 is 2, 2 times 3 is 6, 6 minus 2 is 4, and 3 minus 4 is negative 1. So where this is considered the general solution, when we put the c on it, which we're going to do here, then we know that f of x at this particular point is 3x squared over 2 minus x minus 1. That's a particular solution. Particular. And I know I say the word funny, I know that, but I think it's for emphasis that I say particular so funny. I did not like the way I wrote that. So particular or particular solution, okay? Because if you put c in, so if you put this point, that's your y, so I put the y right there, and the x goes where the x goes in the function. So 2 squared is 4. 4 divided by 2 is 2. 2 times 3 is 6. Sorry. 2 goes into 4. 2 times 3 is 6. Minus 2 is 4. Subtract it from 3, you get negative 1. Plug that in for C, and that's your particular solution. Well, that's all I had for today. So this is a real short one. So hang in there. The next time we're going to talk about, well, what happens if this gets a little tougher? Okay? All right. Come back for video 2. See you then.